Today's Python video topic is Introduction to Data Structures. Currently, we're not following a specific curriculum, so tutorial topics might be a little bit more diverse and unstructured. However, I believe being exposed to real-world coding is very important for developers. For this video and future uploads, the contents will be example projects. They will utilize the knowledge you have already learned from the previous videos, and often introduce you to completely exotic topics. By following the tutorials, I hope you will be able to understand the language Python better. For this specific video, the prerequisite is a good understanding of lists, tuples, dictionaries, and for loops. My video will first cover built-in data structures that you already know as a recap, then cover new concepts arrays, and then by using those arrays, we will learn how to perform the most fundamental level of analysis on a spreadsheet data by using a Pokemon dataset. Data structures are a specialized means of organizing and storing data in computers to perform operations efficiently. In Python, we already know three basic data structures: lists, tuples, and dictionaries. We will have a quick recap of those built-in data structures. The first type we must recognize is lists. Lists are multiple items in a single variable, and they are mutable, meaning that you can change what's inside the list. They use zero indexing, meaning they use integers from zeros to label the locations of each data. Consider list X with three components: apple, banana, and melon. First, you read X. Second, you can search an element in X. Third, you can add an element to X. Fourth, you can delete an element from X. Lastly, you can reassign an element in X. The last three features show the list's mutable nature. Another data structure is tuples. They're just like lists, except that they're immutable, meaning you can change what's inside once you assign a tuple to a variable. Consider list X. Reading and searching are not prohibited. However, attempting to add, delete, or reassign data will cause an error. This is because of the immutable nature of tuples. Of course, reassigning the entire tuple is fine. Dictionaries are just like lists, except that they use key indexing to label the locations of data. You can read, search, add, delete, and reassign just like when you were using lists. Although we have each data structure for a different purpose, I mainly use lists in this video as their representative. Lastly, for loop is a syntax that iterates through items in a data structure one by one. To iterate means to repeat or to loop. Consider list X whose length is 3. Since the length is 3, the time X must be iterated is 3 times. The print result will be the following: apple, banana, melon. So 3 iterations. Even though for loop is widely used, when the size and dimension of data structures increases, the time complexity, or the time it takes to complete the code, increases dramatically. Consider the two lists of lists with shape 3, 5. By the way, in list of lists, we consider the number of elements of a list as the number of rows, and the number of elements in one element as the number of columns. Back to the topic, let's say you want to return the sum of x and y and maintain the shape. How would you code the addition of these two lists? Python will not allow for arithmetic addition because lists are objects, not numerical values. So we have x and y, and we create an empty list L. For every row index and for every column index, we calculate and append the sum to an empty list row. Finally, we append the row 3 times and finish the nested loop. To us humans, element-wise addition sounds like such an easy task, but it's not the same for computers when they deal with lists. Lists are not good enough. We need a new kind of data structure, arrays. A library that allows for the use of arrays is NumPy. You can think of a library as a package of files that don't come with Python, but you need to separately install as you come to need them. Now is the time to install NumPy. To install NumPy, first prepare your terminal. In Windows, type cmd in the Start menu and run the Command Prompt app. In Mac, find the Application Terminal. In the terminal, run pip install NumPy. You won't be able to install NumPy if you don't have pip, which should have been automatically installed when you downloaded Python. In Python text editors, if you want to use NumPy functions, run import NumPy as np, because np is a common way to nickname NumPy in code. The way to turn a normal list into an array is very simple. Wrap np_array function around the list. Array is a unique data structure that NumPy uses. A library that allows for the use of arrays is NumPy. You can think of a library as a package of files that don't come with Python, but you need to separately install as you come to need them. Now is the time to install NumPy. To install NumPy, first prepare your terminal. In Windows, type cmd in the Start menu and run the Command Prompt app. In Mac, find the Application Terminal. In the terminal, run pip install NumPy. You won't be able to install NumPy if you don't have pip, which should have been automatically installed when you downloaded Python. In Python text editors, if you want to use NumPy functions, run import NumPy as np, because np is a common way to nickname NumPy in code. X plus y. Finished. With arrays, addition can be this simple. This also works with all the other arithmetic operations, including subtraction, multiplication, and division. Another interesting feature is that you can change the types of elements super fast. You simply put as type to ensure that every element is casted as a different type. This fast operation is called vectorization. Instead of processing each data individually, vectorization allows the computer to treat a group of data as one element. Then you may wonder, can we vectorize dictionaries? NumPy is a nice vectorization tool of lists, but are we good with it? Consider these tables, and you may realize that all the flat tables we see in real life have dictionary formats. We have these columns that are labeled with keys at the top, and each element of the dictionary is a long list of values. Since NumPy uses zero indexing, using NumPy on dictionary-like objects is impossible. On top of NumPy, developers invented Pandas, a vectorized dictionary library. If NumPy had arrays, Pandas had data frame for 2D tables and series for 1D list. Like dictionaries, data frames use key indexing, not zero integer indexing. Pandas especially shines when the data is too big, which makes it suitable for big data analysis. The installation process is the same, so we'll skip it. To call pandas functions, run import pandas as pd at the top of your Python text editor. Here's how a typical data frame looks like. We can see that columns support key indexing, but it may seem rows support zero indexing. Remember that the default indexing of data frames is zero indexing, but this can be updated with key indexing through a function. One way to see data frames is dictionaries of dictionaries, since both rows and columns support key indexing. Another way to see data frames is a vague group of series stacked together. Each column and each rows are series, a one-dimensional array-like object. Pandas functions are slightly more difficult to grasp since using them might feel like you're using a completely different language. So I recommend you to learn through a project. Before introducing the dataset, let me introduce you to a unique text editor called Jupyter Notebook. It has multiple Python editors called cells in one IPYNB files. A unique feature is that variables are stored in the IPYNB file, not each cell, so they're carried from cells to cells. Google Drive supports Google Colab as a Jupyter Notebook platform. Unlike Google Doc, Spreadsheet, or Slides that you can access by default, Colab must be installed through a separate step. Click New, More, Connect More Apps. Type Colab in the search bar and press Enter. Install the app that you first see. Now you can access Google Colaboratory as a Google app. Once you open the Colab notebook, you'll see the screen. Now it's time to talk about the dataset. This Pokemon Stats dataset is a spreadsheet-like file called CSV. Each data in CSV files is separated with commas, which makes it so easy to read and write. The columns of this dataset are name, type 1, type 2, total, HP, attack, defense, special attack, special defense, speed, generation, and legendary. The legendary column is either true or false. The rows of the dataset are cases for each Pokemon. You don't have to download the dataset since there is a way to load it with a URL without actually downloading it. With Pandas, we will explore the following 8 tasks. Task 1. Find the first 10 Pokemon stats. Task 2. Print a list of Pokemon names. Task 3. Find the first 5 legendary Pokemons. Task 4. Find the strongest and weakest attack values. Task 5. All the special attack values of all the legendary Pokemons. Task 6. All water-type Pokemon and all psychic-type Pokemon fought against each other. If the victory is only determined by the sum of attack values, and if the Pokemon's types are determined by type 1, which type Pokemon won? Task 7. Pikachu attacked Bulbasaur with a normal attack. Can Bulbasaur survive the attack? Last task. Create a new column aggressiveness. Find whether for each Pokemon, attack is greater than defense, and if so, set aggressiveness to 1, and if not, leave it as it is. Time for some coding. Please open the Colab notebook. So this is how Colab would look like when you first make a file. Let's import pandas first. Import pandas as PD. Then let's load the dataset. I uploaded the dataset to my GitHub page, which can be accessed through a link. PD read CSV, https://raw github user content.com, and my username dataset master Pokemon CSV. Alright, let's start with task 1. So task 1 was to find the first 10 Pokemon stats. So task 1. And the way we do it is df head n equals 10. So .head method is the one that allows for printing the first n rows of the data frame. Task 2. Find the list of Pokemon names. This is pretty easy. Just use key indexing for the column name. Remember, it has a dictionary structure. So df name. Task 3. Find the first 5 legendary Pokemons. For this one, we must use a pandas technique called Boolean indexing. When we pass a condition as an index or a key of a data frame, it returns a new data frame with only the rows that satisfy the condition. So legendary df legendary equals true. First 5 rows, legendary. Task 4. Find the strongest and weakest attack values. We're finding attack values, not the Pokemon itself. So task 4. And we are allowed to use max and min methods on the series. That means we can try df attack max and df attack min. This will return a tuple of max and min. Task 5. Find the special attack values of the legendary Pokemon. So this one is pretty clear too. We will use Boolean indexing and then key indexing. Then we will add values method to ensure that we are only getting the special attack values, not the row indices. So it'll be df legendary equals true, and then key indexing special attack. Task 6. All water type Pokemons and all psychic type Pokemons fought against each other. If the victory is only determined by the sum of attack values, and if the Pokemon's types are determined by type 1, which type Pokemon's won? This really sounds complex, but we can just use Boolean indexing and then the sum method to acquire the sum. So it'll look like water sum first. So sum of all attack values of water type Pokemons. So water sum df type 1 equals water attack and then sum method. And then psychic sum df. I'll just copy this part and change this part to ensure that it's psychic. Right? And if water sum is greater than psychic sum, print water. If water sum is less than psychic sum, print psychic. So water is stronger, apparently. Oh, I forgot this. Task 6. Task 7. Pikachu attacked Bulbasaur with a normal attack. Can Bulbasaur endure the attack? Is the remaining HP positive? So again, Boolean indexing, where the name equals Bulbasaur or Pikachu. So Boolean indexing is very important when cleaning data with pandas. So it'll look like remaining HP df name equals Bulbasaur HP values minus df name Pikachu attack values. Values minus values returns a numpy array. Remaining HP 0, print yes. else print no. Task 8. Create a new column aggressiveness. Find whether for each Pokemon attack is greater than defense, and if so, set aggressiveness to 1. If not, leave it as it is. So, task 8. I will need a new column aggressiveness, so df aggressiveness. And I'll set the default value to 0, but it depends on what you want. I'll just set it to 0. For this one, we will use apply function to loop through the dataset. Yeah, loop through. You heard it right. It's not an element by element loop like for loop, but a row by row loop due to vectorization, which is only possible in pandas. So we will define a row scale function, determine aggressiveness row. So attack will be the attack element of the row, and then defense would be defense element of the row. If that attack value is greater than defense, then we will return 1, sorry. And else, otherwise, we'll return what is already set as default, so row aggressiveness. Df aggressiveness. Here's when apply comes to play. Df apply determine aggressiveness, and then we'll say axis 1 and print it. Here's aggressiveness. Thank you for watching.